Today we're on section 3.1, and this new unit is going to introduce us to signed numbers and algebra. Okay, so preparing ourselves for the next course, which is going to be pre-algebra. This is kind of a little prelude. And this first section is about properties of arithmetic. So just no algebra yet, okay? But we're just going to talk a little bit about some of these properties that we already know. We may not have known the name for the particular property, but we're going to connect those two ideas in this section. So the first property is the commutative property. And the commutative property, basically there's one for addition and one for multiplication, okay? And basically it says that we have the ability to add numbers together in either order and still get the same answer, or multiply numbers in either order and get the same answer. So let's see if they have it summarized. Each book is a little bit different, so I'm kind of checking to see how they state it here. Okay, they just use regular numbers. So we'll say for addition, we see that you can do, 4 plus 3, it's going to be equal to 3 plus 4, okay? If we were to use letters in place of numbers or variables, we could say, a plus b is the same as b plus a. The idea that any number that we're adding together, any numbers, we can switch the order and still get the same answer. There's also one for multiplication. And if we kept the same numbers, we could say that 4 times 3 is equal to 3 times 4, okay? In either situation, we get 12 when you multiply, regardless of the order of the numbers. That's the commutative property. Now, one of the ways that I kind of keep this in my mind to connect the idea of switching the order and the name commutative, it kind of reminds me of commuting back and forth to work. Like if you, work in one town, but you live in a different town, then you travel back and forth. That's called commuting, right? And so I think about the commute to work is the same distance when you leave your house to go to work as when you leave work and come back home, okay? It's the same distance going as it is coming back. That commutative property, that kind of back and forth, in my mind, kind of helps me keep in mind that it's a reverse order of the values, but the same amount, okay? The next property is the associative property. And the associative property also deals with numbers in order, but we're not changing the order this time. We'll change the order that we do the calculation, but the order of the numbers does not change, okay? And there's one for addition and subtraction. So for addition, it would look something like, they have 4 first. 4 plus 3 plus 2 is equal to 4 plus 3 plus 2, okay? So far, no change, right? Exactly the same numbers in the same order. What makes this the associative property is that we add parentheses. And we know that parentheses, according to our PEMDAS, or please excuse my dear Aunt Sally, our order of operations, that parentheses go first, okay? So if I put the parentheses here, I know I'm going to do 4 plus 3 and then add 2. Well, I would expect to get the same answer if the parentheses were shifted, all right? If it told me to do 3 plus 2 first and then add 4. In each situation, we'll get the same answer. Now, we didn't change the order of the numbers, we just changed the grouping with the parentheses, okay? That's going to be key, that you understand that if it's associative, the order stays the same. And then we also have multiplication. Same idea, that if it's 4 times 3 times 2, 4 times 3 times 2, that I can group together and do 4 times 3 first, or I can group and do 3 times 2 first, but we'll get the same answer either way. We can see 4 times 3 is 12, 12 times 2 is 24. Over here, 3 times 2 is 6, 6 times 4 is also 24. So we see we get the same answer on each side, no matter which order we do the work. Again, the numbers are the same, just the parentheses differ. And the associative property, to keep in mind that it's the associative property that, deals with the difference in the grouping. I kind of think about our associations, who you associate with, right? So if you have 3 people that are all friends, there are times in those friendships when maybe 2 friends are closer than the other friend, and then maybe it changes. Maybe these 2 friends are a little closer. They're still all 3 friends, right? But just the associations have changed. And again, it's just my own way of keeping track in my mind that the associative property is the one with the parentheses, okay? The groupings. The next one is the distributive property. And for the distributive property, there's also an addition, but then a subtraction version, all right? For the addition, let's see, they've got 2 parentheses, 4 plus 3, okay? So if we're starting with this is a little bit different. We have parentheses, we see there's addition in there, and then there's this 2 in front of the parenthesis. And we remember that if there's a number outside of a parenthesis or 2 parentheses that touch, that means to multiply if they didn't give you a symbol in between, okay? So what the distributive property says is that we could just do 4 plus 3 and then times 2. That would be just according to the order of operations, our PEMDAS. But distributive property gives us another option. It says that we could multiply the values inside by the value in the front. We could take 2 times 4 and add that to 2 times 3. So we're saying it's the same as doing 2 times 4, plus sign is still here, and then 2 times 3. So it's showing us that we're multiplying each value by the number that was in the front, okay? And this might be how they would write it for you to kind of visualize what they've done so you can tell that it was distributed, all right? Now we could go ahead and answer the question or simplify it, but we're just talking about the property, about how we can go from one format to the other. We know this was because of distributive property. If there was subtraction involved, we would do, they've got an example 5 times 6 minus 4. Same situation. We're going to distribute, or we're going to take the 5 and multiply it by the 6, and take the 5 and multiply it by the 4. It just happens to be a minus 4 there. So we have 5 times 6, right? The minus sign will still be here. And then 5 times 4. Like that, okay? So that's distributive property. And to keep in mind that we are distributing, that's kind of how I keep in mind that this is the distributive property. That you can think of the number in front of the parentheses being distributed or given out to each term inside of the parentheses. Now, keep in mind, we're still multiplying because it was, that number multiplied by this answer from the inside. So multiplying it times each part, but keep the sign the same as whatever it was in the parenthesis, okay? And let's see, one more property. And this one, let's see. Oh, never mind. We are putting them together. Let's see. So let's do some examples, and that will help us kind of visualize what's happening here. All right. They want us to solve each problem using the indicated property. The first one says they want us to use the commutative property. And we keep in mind, okay, commutative, that's like commuting. That's the forwards and backwards where I can do them either order and get the same answer. So let's see what they want us to use. So we've got 1/2 times 5 times 6, okay? So with the commutative property, we are able to, instead of having to do 1/2 times 5, which is not gonna, not be as easy to do because we can't cross cancel, we are able to change the order and say, well, I really would prefer to do 1/2 times 6, because then I'd be able to put the 6 over 1. I can make the, cross cancel the 2 and the 6, which would not work with 2 and 5, right? So here, I'm able to change the order, so I can multiply by 6 first, and now I have 3 times 5 for an answer of 15, okay? Now, writing it out necessarily, some of these you don't have to fully write them out, but as you're showing me the particular property, please write it out to show me, all right? I can think, oh, well, 1/2 of 6 is 3, and then 3 times 5 is 15. But just kind of show me for the ones that are being specific about which property, so I'll know that you actually completed it in that order. All right, let's look at B. They want us to use the associative property. And this one has 3.14 times 2 times 5, okay? I noticed that they're all multiplication, right? There's no, add or subtract or some other property or other function. It's only multiplication. So therefore, I can use the associative property and say, and rather than multiplying 3.14 times 2 first, I would rather multiply 2 times 5. Now again, this only works because it's all multiplication and it falls in line with our associative property. So we can say 3.14 times 2 times 5, like this. Because now I can do, 2 times 5 is 10. And multiplying 10 times 3.14 is much easier. I'm just moving the decimal one place. So 31.4. So using that associative property allowed me to change the grouping, right? The associations changed in that problem. And letter C of that same example, using distributive property. So we're starting off with 8, and we're multiplying it by 1,050, okay? Well, what they're saying here is, it might be a little easier to multiply this if I could break down the value inside of here so that I can have a distributive or use the distributive property. Now remember, distributive property only works if you're multiplying the number in the front and distributing it to two parts that have been either added or subtracted. So what they've done is they've broken apart the 1,000 into 1,000 and 50. So they said 8 times 1,000 plus 50. So they just took the 1,050 and separated it into 1,050. Now we can distribute more easily. 8 times 1,000 is 8,000. Oops. And then 8 times our 50. We know 8 times 5 is 40. And then the 0. Okay, and then we can add those two together to get 8,400. Okay, so we'll be using and identifying the properties here and then working some more of these during class.